third graders. We are going to get started going through our lesson today. I've heard so many of you are doing such a good job with going through fractions and getting your work done through iReady or Zern. I just want to encourage you guys to complete some of those lessons and also be working through your packets. If at any point you have a hard time with stuff, just let me know. New packets are available this week, and we'll be starting to review some concepts that you guys have actually already learned involving fractions. Today, we're going to actually continue to go through some of our lessons that are a little bit farther along in the unit, and you guys are actually almost done your unit with fractions. And I will also start completing some videos to go through the review of some of the packets because I want to make sure you guys really understand fractions. This lesson today, it's going to seem a lot more confusing than it really is, but basically it's asking I can decompose whole number fractions greater than 1. So they're asking you, what do those whole numbers actually mean? So we're going to look at a fluency problem really quick, and we're just looking at 1/2 is going to equal what? How many fourths? So we want to go ahead and draw. It's just to draw the shape and then partition it into fourths. So we are going to draw 2 circles. Okay. You want to make sure they're just about the same size. And so our first circle, we knew that this is going to be 1/2. That is 1/2. You can shade it in. Okay. Now it asks you to partition it into fourths to see which one is it going to what is equal to 1/2. How many fourths are equal to 1/2? And if you look, it would actually be 1/4, 2/4. So 2/4 are equal to 1/2. All right. That was just a quick little practice to get our brains working. All right, so our application problem today, we're going to read through it as always. Make sure you have maybe a scrap piece of paper you can work along with us, have some fun colored pens or pencils. We're going to go through this relatively quickly today, and then, but if you have any questions, please don't hesitate to reach out to me. It says, Antonio works on his project for 4/3 hours. His mom tells him that he must spend another 2/3 of an hour on it. Draw a number bond and a number line with copies of thirds to show how long Antonio needs to work all together. Write the amount of time Antonio needs to work all together as a whole number. So first thing we're going to do is we need to figure out how much he originally worked on his project. And we know that that's 4/3. Now we can write 4/3 not in word form, but now as a fraction. So 4/3. And we can actually start to plot that on a number line. Okay, so I'm going to mostly focus on a number line because I do think that it is a helpful representation. Okay, and so my number line obviously is not fully straight, and that's okay. And here I'm going to start with 0, and then I'm going to break it apart in 2/3. So I have 1, 2, right, and here's the number 1. So this would be labeled as 1/3, 2/3, 3/3. Now I want you to see, notice how we still need to go and figure out our number line and plot it at 4/3. So I need to keep going past 1 whole. All right, so I'm going to go ahead and get to 2 now. So this is my whole number of 2. So now if I were to write or label my number line, I now can label this part as 4/3. Notice I have 1/3, 2/3, 3/3, 4/3. So this is how long he spent working on his project. He worked on it for 4/3 of an hour. But his mom tells him that he must spend another 2/3 of an hour on it. Okay, so we need to add 2/3 more. Now what we can do is I'm going to switch colors so that you guys can see exactly what I'm about to do. And so if we added 2/3 more, here I'm going to move this. This is 1/3 more. That would be at 5/3. That's adding one more third. And then I add 2/3. I moved 2 spaces. This is where I land on 6/3, or my whole number of 2. So it's asking you, write the amount of time Antonio needs to work all together as a whole number. And what is the whole number we stopped at? We stopped at 2. So I'm going to briefly show you. So he already stopped at 4/3. He added 2 more thirds of an hour, and he actually needs to work on it for 2 full hours all together. We could also write it as a number bond. All right, we knew that we started with 4/3, and then we added 2/3, which then gives us our whole number of 2 or 6/3. All right, so now we're just going to briefly look at our concept development today, and I want you guys to look at this image and tell me, why is this number bond true? We looked at stuff like this earlier last week. And what you're going to notice is that it's trying to get you guys to think about what this really equals. So if we were to look at the middle, 1/2 and 1/2, that gives us 2 halves, which is also equal to 1 whole. Now, how many fourths do we have right over here? We have 4/4. We have 4/4, and that is also equal to 1 whole. So is this image true? Is this showing us that they all equal 1 whole? Yes, it does. So why is this number bond, why is the number bond true? And the reason why it's true is because 2 halves is equal to 1 whole, and 4/4 is also equal to 1 whole. Now, how does it change if we change the whole to look like this? What is now happening? What did I add in the middle? If you look carefully, I now have 4 halves, right? And we know that 2 halves, all right, so 2 halves, we just said, is equal to 1. And so if I have another 2 halves now added to it, I have another 1 whole. So what is 1 plus 1? That's equal to 2 wholes altogether. I have 2 altogether, 2 wholes, whole figures, if you will. All right, but we just talked about how we had 4/4, right? They're spider legs. And we said that 4/4 is equal to 1 whole. So are our 4/4 equal to 2 wholes? No. So this image is no longer true. We would need to add more fourths. Think about how many more fourths will we need to add to get to 2 wholes. So if I know that I have 4/4 equaling 1 whole, how many more fourths do I need to add to make it to be 2 wholes? You just double it. And so you're going to see that we would just need to add 4 more fourths. If we know that 4/4 equal 1 whole, but in the middle I have 2 wholes, right? I would need to add 4 more fourths, okay, to equal a total of 8 fourths. You might be asking, this is so complicated. Why do we need to know this? And what it's showing you, right, it's showing you that you can break down your whole numbers, the whole numbers. So there's two models you're seeing, and what you're going to be looking at is there's two different ways we can look at making whole numbers with our unit fractions. And so what they did here is they showed you that, remember, we have now four halves or two sets of 2 halves, and that is going to give us a whole number of 2. And I told you that 4 fourths, so 4 of the 1/4, is equal to 1 whole. So we need to add a whole another set of 4 fourths to equal another whole. So we have now 2 wholes. So we have 2 wholes equaling our 2 holes in the middle. But we can actually make that a lot easier. Instead of drawing all of these big, long spider legs, we actually can make it so that we have 4 fourths and 4 fourths. Notice how this is a lot easier to draw. So we still have 2 holes right here, but we said that 4 fourths is equal to 1 whole, and 4 fourths right here is equal to 1 whole. What is 1 plus 1? It equals 2. All right, so right here, it says to draw a number line with endpoints 0 and 2. This is something you can do on your notebook. Label the holes on the bottom of the number line. So I have 0, 1, and 2. You cannot forget about your whole number of 1. We can't just go from 0 to 2 and forget about our 1 whole. Now it asks us to partition the number line into fourths and then label the fractions. So that means between 0 and 1, there needs to be 4 equal spaces. And between 1 and 2, we need to partition that into 4 equal spaces. Okay, so we are going to go ahead and do exactly that. So I have 1, 2, 3, 4. So I have 4 equal spots. And 1, 2, 3, 4 equal spots. Now we're going to label our fractions. We're going to label all of them. This is something I would like to encourage all of you to be doing on your notebooks. So we're going to start with 0. And if we're talking about fourths, 0, how many fourths do I have for the whole number of 0? I have 0 fourths. Okay, now I have 1 fourth, 2 fourths, 3 fourths. Now when we get to our 1 whole, how many fourths do I now have? I have 4 fourths. So 1 whole, 4 fourths. Remember, we talked about how our numerator and our denominator need to be the same number to equal 1 whole. Now that will change as you go into more wholes. So 2 wholes will look a little different. And you're going to see what I mean in just a second. So 4 fourths. Now we keep going. We're adding another fourth to that, and that's 5 fourths. Then 6 fourths. Notice how the bottom number does not change. 7 fourths. And 8 fourths. So number 2, our whole number of 2, that means you have 2 whole figures of fourths. That means you have a total of 8 fourths. Notice how that is not the same as our 1 whole. Okay, so we have 8 fourths. So we have 0 fourths as our whole for 0, 4 fourths for our whole number of 1, and 8 fourths for our whole number of 2. Now, notice how I'm asking those exact same questions. Right here, it says how many fourths are in 0? There are 0 fourths. How many fourths are in 1? There are 4 fourths. And how many fourths are in 2? There are 8 fourths. Okay, now it's asking you below each number or whole number on your number line, draw a number bond. As you draw number bonds, show copies of one whole instead of unit fractions if you can. So you don't need to start and draw one for the 0, but for number 1, okay, what it's asking you to do is to draw the number 1 in the middle for one whole, and then you would have drawn 4 spider legs, each one containing 1 fourth. Okay. Now for our number 2, this is exactly what we were doing earlier. You would draw the number 2. And now instead of drawing 8 spider legs of 1 fourth, you can actually just draw 2 number bonds, or 2 legs of 4 fourths, which is equal to 1, and another 4 fourths, which is another 1. And we know that 1 plus 1 equals 2. So you can see exactly what I did right here. So under the 1, we have 1 fourth plus 1 fourth plus 1 fourth plus 1 fourth, which equals 4 fourths, totals 1. Now we don't want to draw 8 spider legs like we did over here. That takes a long time. So we really want it to make it look like this. Okay, so 2, our whole number of 2, is equal to 4 fourths plus 4 fourths, which equals a whole number of 2. Now you are going to see there's going to be a worksheet for you guys to just briefly work on. And what it's just going to be asking you to do is just to be thinking about how many fractions, how much of that fractional unit is in a whole number. So for example, how many halves are in 0? There are 0 halves, right? There are 0 halves. But then how many, if we were to break this into halves, right? How many halves are in one whole? So I would have 1 half, 2 halves, right? So this is 2 halves. There are 2 halves in one whole. There are 2 halves in one whole. And you would just need to make 2 spider legs, each of them containing 1 half. Then if I move on, I go, okay, that's 3 halves. And then this one would be, how many halves do I now have for 2 wholes? I have 4 halves. And I can represent that by doing 2 halves plus 2 halves equals 2 wholes. All right, you're going to have some practice looking at this. But before I have you guys go and practice, I just want to briefly walk you through a video that would be really helpful for us to look at. So I'm going to just have us look at this. This continues our whole numbers for a little bit further. All right, and so you can see that 0 is how many fifths? It's 0 fifths. 1 is how many fifths? It's 5 fifths. Now, how many fifths do you think there is going to be in 2 wholes? Now, 2 is going to equal 10 fifths. 3, what do you think it's going to be? 3 is going to equal 15 fifths. Now, what do you think about 4? 4 is now equal to 20 fifths. Now, I want you guys to think about what did they just skip count by? They just skip counted by 5, because then we know there's 5 equal sections between each whole number. So they went from 0 to 5 fifths to 10 fifths, 15 fifths, 20 fifths. So if I were to give you a whole number of 5, what do you think it would be as a fraction? 5 would equal 25 fifths. I know you guys can do this. Labeling whole numbers as a fraction, you can absolutely do that. So what the goal of our activity will be is to just label those whole numbers as fractions. Have an awesome day. I'm super proud of you guys. Keep working hard.